A recursive equation is one that defines each value based on the previous values. This differs from all of the functions that you are used to, in which you can plug in any value at any point for the independent variable x to find the corresponding dependent variable y. So in a recursive equation, you are going to have a variables, and then you're going to have in subscript next to the a's different things. You could either have a 1, a sub 1. Does anyone want to take a guess at what this could mean? A sub 1.
Maybe the a is x and the subscript of 1 is y?
So the entire term is a variable. A sub 1 is the variable. The subscript 1 tells you what term position it is. So a sub 1 is the first term. The subscript letter is the position number. So if I had a list of numbers, the first position is 1, and the entire term's value is a sub 1. Then a sub n again, the subscript n is your position. So a sub n is what I like to call the term you're trying to find, or your current term. There isn't really a good name for this one. If a sub n is your current term, what do you think a sub n minus 1 would be? It's your previous term. It's the term that came right before a sub n. And what do you think a sub n plus 1 would be? Your future term, your next term. So we have a few examples on how to create the recursive equations. Notice here we have a list of numbers: 5, 13, 21, 29. The first thing you need to do is recognize the pattern occurring for this list of numbers. What pattern can you identify? What? Each time we are adding 8 to get to the next term. Whoops, not times, plus. Each time we're adding 8 to get to the next term. So to write what is called our recursive equation, you write a sub n, meaning the term that you're trying to find, your current term, is equal to a sub n minus 1, which, what was that again? The previous term, the past term. And then what did we do to the previous term to get our current term? We added 8. So say I'm trying to find the third term, a sub 3. You would find it by using the recursive equation. A sub 3 is equal to, now a sub 3 minus 1 is how much? A sub 2 plus 8. What was the a sub 2's value? 13. So we would do 13 plus 8 and get what? 21. This is how we can use the recursive equations. As long as we have the previous term, we can know our current term. Now, always with recursive equations, you need to state what the first term was. So you write, after you write your equation, you put a comma, and you write a sub 1 equals whatever your first term's value was. What was the first term's value? 5. So you write a sub 1 equals 5. So let's try it again. We have 0.4, comma 2, comma 10, comma 50. What is happening here? What pattern do you recognize? You're multiplying by 5 times 5 times 5 times 5. So what we do is we write a sub n, and we are multiplying each time. So we multiply the previous term, a sub n minus 1, by 5. And then we have to write down our first term, a sub 1, was equal to 0.4. So let's actually try it instead of just looking at those examples. We have 2, 4, 8, 16, 32. What pattern do you see? It's times what now? 2. We're multiplying by 2 every time. So how do I start off writing my recursive equation? What do we always start with? What goes in front? What do we write in front? A sub n equals. Then what was happening to our previous term to get our next term? You're multiplying it by 2. So you write 2 times a sub n minus 1. This means to get your current term, you multiply your previous term by 2. And then we always need to state what the first term was, which is what? 2. So a sub 1 equals 2. Let's try another one. What's happening in number 2? This time we're adding 2 to go from 1 to 3 to 5 to 7 to 9, plus 2, plus 2, plus 2, plus 2. And by the way, we always need to be doing the same operation. So our recursive equation, how would I write it? A sub n is equal to, what are we doing to our previous term? Multiplying, adding, subtracting, what are we doing to it? Adding to it. So you write your previous term, a sub n minus 1, and we're adding how much? 2. And then we state our first term, which is 1. A sub 1 equals 1. Let's do it again. 8421.5. What are we doing? We are dividing by 2. Or, what's the same thing as dividing by 2? Multiplying by 1/2. You can do either. You can write either. Divide by 2 or multiply by 1/2. You can either do that or just write a sub n equals 1/2 a sub n minus 1. So you can either write 1/2 a sub n minus 1 or a sub n minus 1 divided by 2. And then we state our first term, a sub 1 equals 8. So what pattern did you identify, Savannah? What did you notice we're multiplying by each time? Just look at the numerators. What times 2 gives you 3? I'm sorry. What times 2 gives you 6? Three. So we're multiplying by 3 every time. So, how do I start my equation? 8 and f. What's the first thing I write? Good. A sub n equals. And then what do you think goes next, Yuri? What do we write next?
3.
Yes. And then what goes after the 3, 8, and d? A sub n minus 1. And then after our equation is complete, Oscar, what do we have to state? Beautiful. A sub 1 equals 2/5. Wonderful, guys. I want you to go ahead and do 5 and 6. What pattern did you identify 8 and S? What was happening on number 5?
It's double times.
Yes, good. We're multiplying by 2 every time. So, what was the first thing we wrote for our recursive equation? Richard.
4, 0, 1, 5.
Number 5, yeah.
Okay. A sub n
Good.
equals
And then Liz. For number 5, we started with a sub n equals. What comes next in our recursive equation?
2 times a sub n minus 1.
Perfect. And then what do we state at the end there, Eli? For number 5. Perfect. A sub 1 equals 0.01. What pattern did you identify for number 6, Kaylee? You are dividing by 9 each time. So, how do we start our recursive equation? Mariella, what is the first thing we write for number 6? Mariella, yeah. Number 6, what's the first thing we write in the equation? Yes, a sub n, good. And then what's the next thing we write, Mateo? We write that a sub n minus 1 over 9. This is the other way that we could have written it. Remember, Up here I said there was 2 ways we can write division. Up on number 3 we wrote 1/2 times a sub n minus 1. Well, on number 6 we can also write a sub n equals a sub n equals a sub n minus 1 over 9. We can write it either way. And then what do we have to state in the end, Lily? Good. A sub 1 equals 18. Wonderful. All right, guys. We are now going to do the other type of equation, regression equation. I need for every single person to have a calculator. If you do not, grab a calculator right now. So now we're going to be using regression to create these equations. So it says when given a set of data that represents an exponential equation, you can use the regression function in a calculator to find the equation. Use the following steps. So first thing you're going to do is take out your calculator. And you are going to go to Stat, Edit. So Stat is that button right under Delete, D-E-L. We're clicking on Stat, S-T-A-T. Then, when it's highlighted on Edit, which it already should be, you're going to press Enter. This is where you are going to write down the data sets. So these are lists, they're called. L1, L2, L3 means list 1, list 2, list 3. In L1, you are going to write your X values. So we're going to do this exact example like you see on the screen. So in L1, we're typing in our X values, which are 1. You type in 1 and then hit either Enter or the down arrow key. 2, Enter. 3, Enter. 4, Enter. 5, Enter. 6, Enter. And then, in list 2, this is where you put your Y values. 200, enter. 100, enter. 50, enter. 25, 12.5, and 6.25. Everyone should be making sure you're actually doing this so that you can actually get the same answer I do. So then you're going to hit Stat again. You're going to go over to Calc this time. C-A-L-C means calculate, calc. We're trying to calculate. You scroll up. Nope. We're going to scroll down. We're trying to calculate an exponential regression equation. You can click 0 to get there quickly if you would like. But we're trying to get to exponential regression. X-reg. And you click Enter. Now these are kind of somewhat cool, or maybe they skipped a step when they were writing this down. But what you do from here is you just continuously press Enter, Enter, Enter. Now, I won't tell you. There's a way that you can store this so that it immediately puts it into Y equals for you. But in Algebra 2, I don't think that we're doing too much with these equations where you would need to store them to do future things. So we're going to skip that step. So you're just going to click Enter, 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 enter. And it should give you this. Y equals A times B raised to the power of X, where A is 400 and B is 0.5. So all you have to do from here is substitute those values in to the first equation. Instead of writing A, you're going to write 400. Instead of writing B, you're going to write 0.5. And this is the equation you would write down when it asks for the exponential equation. This is the final answer. So let's try it. We're going to hit what first to calculate the exponential equation here? What do we hit first? Stat edit. And if you want to clear the list all in one go, scroll up to the L2 or L1 and press clear. And then scroll down. Clear. Scroll down. So the first row is always your X values. The second row is your Y values. So our X values are 1, enter, 2, enter, 3, enter, whoops, 2, enter, 3, enter, 4, 5, 6. And we have 1, 1.25, 1.563. And yes, you have to write the entire decimal. 1.953, 2.441, 3.052. From here, what do we write? Or what do we hit? Sorry. Stat, and then we go to calc. Whoops. Stat, calc, 0. Enter, 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 enter. And this is what you get. So my exponential equation is what? What do I write down? Just round to the hundredths place. 0.80. And then what's our base? Power of X. And we're done. It does then want us to find what the 10th value is. How can you do it? You just type in 0.80 times 1.25 raised to the power of 10. And you get 7.451. You guys try to find the exponential equation for the next one. Go ahead and type these in and find the next exponential equation. Volunteer for what they got for the equation. What was that first A value? 1.25. And what was the B? What was it? 0.80. Oh, so it's just reversed. And we put an X on that B value. And what was the 10th term? What was it? 0.134. Wonderful. So now, let's see if we can't find the the recursive equation for both of those. If it's very hard for you to see what you're multiplying by each time, there's a trick. You can take the next term and divide it by the first to figure out what you're multiplying by. So you do, in this case, 1.25 divided by 1 means we're multiplying by 1.25. And we check, okay, is that the same every time? Take 1.563 and divide it by the previous term to figure out what you multiply by. We're multiplying by, again, 1.25. And in fact, each time you check, okay, yes, we're multiplying by 1.25. Now, it's not an exact multiplication because what they've done is they've rounded each one of these. So that means that it's not giving you the exact rate. But we can round and the rate is 1.25. Now, another thing that you could have done to figure out what you're multiplying by is the base in our exponential equation is always going to be what you multiply by. So using this, let's write our recursive equation. A sub n equals, what are we multiplying by? 1.25 times a sub n minus 1. And what was our first term? 1. So just looking at our exponential equation for number 2, let's write the recursive equation. What are we multiplying by? 0.8 this time. 0.80 times a sub n minus 1. And what was our first term? You always just multiply by that base number your calculator gave you. So now I want you to fully do number 3. Fully do number 3.